In this video I'm going to be talking about the various types of work holding device which can be used on the lathe. In the videos which we've produced up to now, we've always been using the basic standard 3-jaw chuck. The 3-jaw chuck is self-centering, which means that when the jaws are opened and closed, they move in and out simultaneously, and when a piece of circular bar is clamped in the jaws, it automatically centralises the circular workpiece so that the workpiece is central to the spindle centre line. For that reason, this chuck is called a 3-jaw self-centering chuck. Obviously the uses of this type of chuck are limited, and we have several other methods of holding work to increase the versatility of the lathe and to increase the range of types of workpiece which can be held. I'm going to demonstrate how to remove a chuck and fit another workpiece type of work holding device. The work holding devices are clamped onto the spindle face by a cam lock mechanism. The cam lock mechanism consists of a series of 3 screws, 1, 2, 3, and each of the screws has a cam inside of it. The work holding device has 3 pins which locate inside the face of the spindle, and when the cam locks are tightened, it pulls the work holding device back and tightly onto the face of the spindle. When removing and fitting work holding devices onto the lathe, care must be taken to make sure that the work holding device doesn't drop and fall onto the slide rails of the bed. If these are damaged, it can make the machine inoperable in worst case, or inaccurate. For that reason, we have hard rubber pads which we place underneath the work holding device on top of the lathe bed, and this will protect the lathe bed from damage when we're handling the work holding devices. To remove, each of the 3 cam lock screws needs to be unlocked using a special square key, rotated anti-clockwise so that the small mark on the cam lock screw is in line with the mark on the spindle, which is at the 12 o'clock position. This needs to be done for all 3 of the locking screws. Once all 3 have been slackened and aligned with the mark, sometimes the chuck will come loose. However, on the face of the spindle there is a small taper which is a locking taper. It's very similar to the method which is used to lock tools into the tailstock using a Morse taper. To release the lock on the taper, it's common to tap the top of the chuck with a copper mallet. We never use a hammer. The copper mallet won't damage the chuck. So you'll see that when I tap this, the chuck comes loose. The chuck won't fall off because it's still held on the cam lock pins. So you need to carefully support the underside of the chuck, taking care to make sure that your fingers aren't underneath, and carefully remove the chuck and lay it on the rubber pad. Turning the chuck around, we can see the 3 cam lock pins and also the internal taper inside of the chuck. On the face of the spindle, we can see the external taper, locking taper, and also the 3 holes which the cam lock pins fit into. The cams lock onto these semicircular cutouts on each of the pins, and as they're tightened, they pull the pin backwards so that the face of the work holding device and the taper are locked onto the face of the spindle and the spindle taper. I'm now going to fit a different work holding device, in this case a 4-jaw chuck. The 4-jaw chuck is commonly used to grip square shaped workpieces, rectangular shaped workpieces, and because it's got independent movement of each of the 4 jaws, in other words, each of the 4 jaws can be positioned independently of the others. It's not self-centering. That means that, as well as rectangular and square pieces, it can grip a range of shapes, virtually any shape within the range of the jaw travel. The jaw has the same locking mechanism and the 3 cam lock pins, internal taper which matches the spindle nose. Care must be taken when fitting any kind of work holding device to make sure that the mating faces and the taper are perfectly clean. So the spindle face and external taper should be cleaned on the spindle nose, and also the cam lock pins, the mating face and the internal taper on the work holding device should be cleaned thoroughly. The work holding device can then be turned around and moved so that it's close to the chuck face, and then carefully lifted, making sure that you have a good firm hold, and the cam lock pins fitted into the spindle. At that point, you should push the work holding device firmly up against the spindle face and put the key into the first cam lock screw and turn it lightly until it's just very lightly nipped. That will secure the chuck onto the spindle face. You then need to turn to the second cam lock screw and also tighten that one lightly. And finally the third cam lock screw and tighten that one lightly. Once you're sure that the chuck has been fitted correctly and there are no gaps between the mating faces, you can then go to the first cam lock screw and tighten it fully. Second screw, third screw. One final check. All 3 are tight. As can be seen in the photo which follows this section, the mark on the cam lock screw should be in between the V mark, which is at 3 o'clock, and the V mark, which is at 6 o'clock. If the mark on the cam lock screw is not in between the 2 V's when the screw is fully tightened, that means there is something not right with one of the cam lock pins, and that would have to be investigated and adjusted. So the chuck is now fitted onto the spindle and is safe to use.